Which of the following IP addresses is not a private IP address? If we come here and look at the range for the private IP addresses, going to see that we have 49. I didn't see any 49 here, right? So going to pick this 49.69. That's the most likely answer. .147.197, and here we go. Which of the following IP addresses is not a valid IP address? We are having 305 here, which is way above 255. Don't forget that we said the range is 0 to 255, 0 being the network address and 255 being the broadcast address. So this 305 is not it. It's not a valid IP address. Move to UDP and TCP, which are protocols for the network layer. The IP protocol allows us to reach a destination host on the network. The host is identified by its IP address. We need protocols that will enable processes on network hosts to communicate with each other. There are two transport protocols to achieve that, the UDP and the TCP. User Datagram Protocol, UDP, allows us to reach a specific process on this target host. UDP is a simple connectionless protocol that operates at the transport layer, that is layer 4. Being connectionless means that it does not need to establish a connection. UDP does not even provide a mechanism to know that the packet has been delivered. An IP address identifies the host. We need a mechanism to determine the sending and receiving process, which can be achieved by using port numbers. A port number uses 2 octets. Consequently, it ranges from 1 and 65535, but 0 is reserved. And how do we come about this number? It's just by calculating the expression 2 raised to power 16 minus 1. Just the similar way if you want to transfer data from your phone to the laptop and you're not using a wireless connection, rather, you most likely are going to use a data cable and it's going to enter a port like hardware port. So that's just what this port means abstractly, like not hardware but the concept here. So a real life example similar to UDP is the standard mail service with no delivery confirmation. In other words, there is no guarantee that the UDP packet has been received successfully. Similar to the case of sending a parcel using standard mail with no confirmation of delivery. In the case of standard mail, it means a cheaper cost than the mail delivery options with confirmation. Likewise, in the case of UDP, it means better speed than a transport protocol that provides confirmation. But what if we want a transport protocol that acknowledges received packets? That's where we have our TCP, Transmission Control Protocol. This is a connection-oriented transport protocol, and it uses various mechanisms to ensure reliable data delivery sent by the different processes on the network hosts. Like UDP, it is a layer 4 protocol. Being connection-oriented, it requires the establishment of a TCP connection before any data can be sent. In TCP, each data octet has a sequence number, which makes it easy for the receiver to identify lost or duplicated packets. The receiver, on the other hand, acknowledges the reception of data with an acknowledgement number specifying the last received octet. A TCP connection is established using what is called a three-way handshake. 2 flags are used, which is the SYN and the ACK. SYN as in synchronize and ACK as in acknowledgement. And the packets are sent as follows. The SYN packet, the client will initiate the connection by sending a SYN packet to the server. This packet contains the client's randomly chosen initial sequence number. The SYN ACK packet, the server responds to the SYN packet with a SYN ACK packet which has the initial sequence number randomly chosen by the server. The ACK packet. The three-way handshake is completed as the client sends an ACK packet to acknowledge the reception of seen ACK packet. Let's assume we have A trying to connect to B. A sends seen packet to B. B sends seen ACK packet, let them know that they've received the seen packet. Then A responds with ACK packet. So similar to UDP, TCP identifies the process of waiting or initiating for a connection using port numbers. As stated, a valid port number ranges from 1 to 65535 because it uses 2 octets and port 0 is reserved. Now, which protocol requires a three-way handshake? That's our TCP. And what is the approximate number of port numbers in thousand? Approximate, is that 66? Okay, let's try 65. Oh, right. Encapsulation. Before wrapping up, it is crucial to explain another key concept, which is encapsulation. In this context, encapsulation refers to the process of every layer adding a header and sometimes a trailer to the received unit of data and sending the encapsulated unit to the layer below. Encapsulation is an essential concept as it allows each layer to focus on its intended function. In the image below, we have the following 4 steps. We have the application. Where is our image? Let me minimize my attack box. Right. Okay, this is our image. We have the application data, the TCP segment or the UDP datagram. We have the network packet and the data link frame. Now, this application data starts when the user inputs the data that they want to send into the application. The application formats this data and now starts sending it according to the application protocol used, using the layer below it, the transport layer. Don't forget, we are using the TCP IP model to explain encapsulation here. The transport layer we use either the TCP segment or UDP datagram after it has added the proper header information. So after the information has been added, it either becomes a datagram or a segment. Now, the network layer, we had an IP header to the received TCP segment or UDP datagram, and it is called IP packet, which is sent to the layer below it. The layer below it, which is the data link layer, we now receive the IP packet and add the proper header and trailer, creating a frame. So at different layers, data is called different things. The process has to be reversed on the receiving end until the application data is extracted. Now let's explain the life of a packet. Based on what we have studied so far, we can explain a simplified version of the packet's life. Let's consider the scenario where you search for a room on TryAcme. On the TryAcme search page, you enter your search query and you hit enter, just as we did before we began this lesson. Your web browser will use the HTTPS protocol, prepares an HTTP request and pushes it to the layer below it, which is the transport layer. The TCP layer needs to establish a connection via a three-way handshake between your browser and the TryAcme web server. After establishing the TCP connection, it can send the HTTP request containing the search query. Each TCP segment created is sent to the layer below it, that is the internet layer. The IP layer adds the source IP address, that is your computer, and the destination IP address, that is the IP address of the TryAcme web server. For this packet to reach the router, your laptop delivers it to the layer below it, which is the data link layer. Depending on the protocol, the link layer adds the proper link layer header and trailer, and the packet is sent to the router. The router removes the link layer header and trailer, inspects the IP destination among other fields, and routes the packet to the proper link. Each router repeats this process until it reaches the router of the target server. This step will then be reversed as the packet reaches the router of the destination network. As we cover additional protocols, we'll revisit this exercise and create a more in-depth version. On a Wi-Fi, within what will an IP packet be encapsulated? That should be the frame, right? What do you call the UDP data unit that encapsulates the application data? Call it UDP datagram. What do you call the data unit that encapsulates the application data sent over TCP? Called TCP segments. Now we have, okay, we are supposed to start this machine, start machine. And also we've started our attack box. I'm just going to show split view. So we start the attack box, give it about 2 minutes to properly boot. And we need to start the terminal on the attack box to experiment with Telnet. So be experimenting with Telnet today. Telnet, which means teletype network, is a network protocol for remote terminal connection. In simpler words, Telnet allows you to connect to and communicate with a remote system and issue text commands. Although initially it was used for remote administration, we can use Telnet to connect to any server listening on a TCP port number. On the target virtual machine, different services are running. We are going to experiment with 3 of them: the echo server, the daytime server, and the web server. This server echoes everything you send it. By default, it listens on port 7. The daytime server listens on port 13 and replies with the current day and time. And the HTTP server listens on port 80 by default, and it serves web pages. Before continuing, we should mention that the echo and daytime servers are considered security risks and should not be run. However, we started them explicitly to demonstrate communication with the server using Telnet. In the terminal below, we are going to connect the target VM at the echo server TCP port number 7, and to close the connection, we are going to press the Ctrl J key simultaneously. So what do you want to do here? Okay, I think we have our machine started up already. 10.10.133.232, which is also what we have here. So we're going to use the sync pass, the telnet, the IP address, and the port number, which is 7. Okay, you connected, then you type hi. Don't forget it is echo, so what it means, whatever you send it, it's going to send it back to you. It just like echoes what you send to it. My name is Toybat, so it's going to send exactly that back to me. And if you want to close it, we press Ctrl J. Interesting. Why is my, oh, I saw J. Oh, sorry. It's control and the brackets. Yeah. We're going to type create and it's going to close the connection. My bad. So in the second terminal, we are going to connect the daytime server listening at port 30. Just like the previous syntax, we use telnet, the IP address 133.232 and the port number 13. And we can see we have our response Sunday, February 2, 2:46 a.m. UTC 2025. That's the current time. Now finally, let's request a web page using Telnet. After connecting to port 80, you need to issue the command get HTTP 1.1 and identify the host where anything goes. Next, you need to press enter twice. So your last input line is a blank line. You may have to press enter after sending the information in case you don't get the response. Okay, let's just follow what is being explained here. Telnet, the IP address, let's not forget 10.10.133. Oh, we have an extra 0. .232 and port number, which is port 80, and press enter. So you're going to give it a command get slash http slash 1.1. What else it has to do? And identify. You need to issue the command and identify the host. So it will enter, press host telnet.thm. Then you need to press enter twice. We are good. So we have our response. We have the 200 OK. Last time it was modified was January 20, 2020, June 20, 2024. And we have our flag also. So use Telnet to connect the web server on this. What is the name and version of the HTTP server? This is the server. It is called Lite TPD version 1.4.63. So we're having Lite TPD slash 1.4.63. We have our answer. What flag did you get when you view the page? We have try Acme, Telnet. Don't worry, it's not case sensitive. Just have to make sure you use the right space bar. In conclusion, we covered the OSI model, the TCP/IP model. We compared and contrasted the two. We also covered the IP addresses and subnets. We briefly explained routing. Furthermore, we dived into TCP and UDP. And we also use Telnet to talk to different servers over TCP. You can actually go to the next room. I believe that's a premium room. If you have the subscription, you can take the room. But here we are going to complete, and we are at the end of our tutorial for today. If you have any question, feel free to ask me. I'll be more than willing to help. Bye.